Hello, in today's video we're going to be talking about J.J. Thomson's model and Rutherford's model, and this is by Amir, Adrian, Ina, and Olivia. Thomas's atomic model is the earliest theoretical model of the inside of an atom proposed by William Thomson and supported by J.J. Thomson, who previously discovered the electron. The model that Thomson created is called the plum pudding model because of its resemblance to plum pudding. Thomas found the electron when experimenting with a tube that was Crookes, or cathode ray. He had shown that the cathode rays were charged negatively, thus coming to the realization there were negative charges in atoms that the current model of atoms did not account for. These negative charges were electrons.
When J.J. Thomson discovered the electron, he also realized that atoms usually have a neutral charge. So, he came to the conclusion that there had to be a source of a positive charge in the atom. Or else, how would the negative charge of an electron be balanced out? This positive charge was the proton. Though he didn't know the exact location of these charges in the atom. So, he believed that the atoms were surrounded by positive and negative charges. J.J. Thomson just kind of threw the charges everywhere and therefore led to the creation of the plum pudding model. However, there was no experimental proof or evidence that this model was correct, and it left a lot of unanswered questions about atoms. With the uncertainty of the plum pudding model, Ernest Rutherford used an experiment called the gold foil experiment that eventually disproved the plum pudding model.
Ernest Rutherford, a physicist from New Zealand, would perform his own experiments in 1909 with fellow physicist Hans Geiger and undergraduate Ernest Marsden. In his famous gold foil experiment, Rutherford fired a thin beam of alpha particles at a very thin sheet of pure gold. Alpha particles are the nuclei of helium, made up of 2 protons and 2 neutrons. In this case, Rutherford placed a sample of radium, a radioactive metal, inside a lead box with a small pinhole in it. A thin beam of alpha particles escaped out of the pinhole in the direction of the gold foil, which was surrounded by a detector screen that would flash when hit with an alpha particle. Rutherford predicted that most of the alpha particles would pass through the gold foil. This was because in Thomson's plum pudding model, protons were spread out amongst the atom, so it was assumed the proton's positive charge would spread out throughout the entire volume of the atom. Therefore, it would be too weak to affect the path of the fast-moving alpha particles.
The results of the experiment shocked Rutherford. While almost all alpha particles passed straight through the gold foil, a few alpha particles, about 1 in 20,000, were deflected more than 90 degrees from their path. Because of this, Rutherford realized that positive charges must be somewhere in very small volume of the atom, also containing an atom's mass, explaining how some of the particles were deflected drastically. Also, because the alpha particles pass through the foil, atoms must mainly be made of empty space. Rutherford's model, the nuclear model, described the atom as a tiny, dense, positively charged core called the nucleus, in which nearly all the mass is concentrated, around which the light, negative electrons orbit at a distance, like planets revolving around the sun.